Hey folks, welcome to another episode of ASP.NET Core from Zero to Overkill. In this episode, we'll take a look at modeling our domain errors in a more explicit way and minimizing exceptions, and we'll make use of a couple of types, either an error, to achieve this. So the goal is to avoid using exceptions for domain logic. So we make the handling of these errors that are common, if we are putting them in the domain logic, means there are domain errors and there are things that might happen from time to time, not really, and shouldn't be exceptions, because exceptions should be exceptional. And when we start throwing exceptions for business errors, we have a problem, because it's not exceptional, it's something we expect to happen when we try to do something that makes no sense from the business point of view. It's different from failing to connect to a server or something like that. It's not the same kind of thing, so we probably should model that in a different way. So to achieve this, we'll go through some steps. So we'll start by creating what I've called, because of reasons, a robust error type, and we'll implement it as a tagged union. I'll show you in a minute what does this mean. Then we'll introduce the either type, which is common in functional languages, maybe not that much in C# land, but we'll make use of it. Then after we get started with this either type, we will build upon it to have some capabilities that will help us bringing it all together in the end, the either type, the error type, and everything we implemented so far, in this case in the group management API, which is our example until now that we are using for implementing all of these things. And just before getting into code, the usual plugs. If the videos are being useful, please consider dropping a like, sharing them, and leaving feedback. All of them important to make the channel grow, but probably the third is the more important, to help improve the future videos. And besides that, remember, in the blog I normally put the video and a blog post at the same time, because some people prefer to read, others watch videos, and even if you don't prefer to read, it's nice to have the thing static and copy paste some code, stuff like that, and it's easier to find on the internet. If you want to ask some questions and stuff like that, you can use Twitter. Also, I've been streaming on Twitch, so sometimes I prepare the episodes in there, other times I do something else, so feel free to drop by. Otherwise, I also upload the archive to YouTube. And for more contacts, if Twitter or YouTube is not enough, you can visit the blog or my personal website, and there are other alternatives. So with all of this out of the way, let's get to code. So let's get back here to the points, and let's start with creating a robust error type. For starters, what do I mean by robust? So before getting into the actual code, let's go here to a Visual Studio Code window just for us to see. So imagine we want to model this error type. So probably what would be the first approach? Maybe when we want to say an error occurred of this type, maybe the first thing that comes to mind is creating an enum. So we could do something like public enum error, and we put there, probably the most common we have so far in this application would be not found, for when we can't find some, for instance, we can't find a group that was asked for, or we can have something invalid when we try to rename a group to an empty string which isn't valid from the domain perspective, or something like unauthorized. In cases we try to edit a group but we are not administrators. So this would be the first approach, in simple approach. Would it work? Yes, kind of. The problem, imagine we want to have some information or some details along with this error. With just an enum, we can't do that. So alternatives. Maybe we make this instead error type and create a public class error, and then we might just put a public error which has an error type and a message, and we just do type equals type and message equals message, and then we have a couple of properties. We have a couple of properties. So it's better. We can use this class and return it. We have a type, we have a message. Yeah, simple enough. Some problems. Maybe different errors have different needs. For instance, not found, maybe for the not found a message is enough. But imagine that for invalid, instead of a message, we want to add specific information for each invalid. For instance, we try to edit the group and we try to use an invalid name and an invalid something else. So we want various messages for different things. In this case, what would you do? We could just add more properties for different things. Like, I don't know, just inventing a bit. Messages, and then depending on the type we would use messages or message, which would mean we add more properties, but then the client of this class needs to know which properties to use depending on the type. So maybe not the best approach, and the class would get a lot of things and it would be hard to understand what to do. So other alternatives. Let me copy paste something which is easier. Maybe another alternative could be something like this. Instead of an error type enum and then an error, we could, for instance, have an abstract error and then have an actual type for each one. In this case, they're all pretty much the same with a message, but imagine that invalid instead of a string could get string array. It's possible, something like that. So in this case, they would all be errors, could be returned from our business logic. When we return an error saying do this, this is wrong, this happened, something like that. But then each error has the exact information it needs. So the client, given the type, can do whatever it takes. So this would be not bad, I think. And this is where, let me get back here, we are going through the steps of this creating a robust error type. And now we get to one reason why we would like to implement an error type as a tagged union. So as we have this implemented right here, we would need for the clients to always know all the types of so So we'd get an error, and the client would probably do an if. Is it not found? Then I'll do this. Is it invalid? Then do this. Unauthorized? Do this. The problem. What happens if we go and add another one? I don't know. Unexpected. I'll put it here. We must remember to go to all the places where the errors are being used and put this. It can be done, but we might forget. It's not the greatest thing. So then enters this notion of a tagged union, or from Wikipedia, tag union, variant record, choice type, discriminated union, disjoint union, some type, or co-product. What a lot of names. But what's important is a data structure used to hold a value that could take several but fixed types. So the most basic example is the enum. An enum is a tagged union where the problem is, in case of C#, it's different in other languages, but in case of C#, which is just basically an int or something like that, and we can't put extra information in there. That's one of the problems. But it's an example of a simple tagged union. Another problem, but that is more a C# problem and not really the enum specifically, is that, for instance, switch cases are not, how's it called, exhaustive. So if we add a new enum value and we forget to put it in the switch, we forget. So one thing we can do is to implement a tagged union in C#, resorting to the visitor pattern. So because C# doesn't have great support to implement, or no support to implement tagged unions like other languages have, particularly functional languages, and Kotlin also has it, but C# doesn't. So we can use traditional object-oriented patterns to implement a tagged union to make this happen. So we saw this basic version. So now let's look at the actual implementation. So over here in the domain project, again, in this case, error makes sense to be here in this shared part of the domain, but there are other things like optional, and either probably shouldn't be in the shared. I should move it to another project because it's not really domain, but I'll do it eventually. But error should be in the domain because we can create errors dependent on the business logic. In this case, my examples aren't great because I'm mapping the errors too much to like invalid, not found, because it's kind of useful, but we can have specific errors for business cases. So let's see. So we have, I'll left this for later, ignore this part for now, but just look that we have an abstract error class with a private constructor. So the idea is that we cannot inherit from the error class outside of it. So all the implementations, all the classes that inherit from it are internal classes. So we have the not found in here, we have invalid, and we have unauthorized. All internal to the error class and all sealed. Why is the need for this? So the idea is that by not being able to do this outside, we cannot break our inheritance. It's like a closed inheritance chain tree. So it's controlled over here. If we were able to inherit from error somewhere else, the clients of this class wouldn't be able to be sure that they had all the possibilities covered. But by doing a closed hierarchy, we can ensure that, so the clients always know that no other error can happen besides these ones. So by doing this, we know that we will only get not found or invalid or unauthorized, and if we want a new one, we put it in here. This in conjunction with the visitor pattern, and that's where this except comes in. So error as an abstract except method that its derived classes need to implement. And the idea is that this visitor has a method to visit for not found, invalid, and unauthorized. So one method for each derived class. The idea is to ensure that all are covered. And when we go here, the accept method calls the visit with this, so it will call the correct method given not found, invalid, or unauthorized. Now, why is this relevant? So remember that I mentioned that unexpected. So imagine we want to add a new unexpected type of error. So I copy this part and put here unexpected. And now you see that this visit doesn't work because there is no method that receives an unexpected. So we must change this interface to receive unexpected. And now it compiles this part. But I haven't shown you yet, but I have an implementation of this error visitor, which is for a client to be able to handle these kinds of errors. And if I try to rebuild, ignore the warnings because I'm not handling the nullable reference types correctly. Now we have a compilation error because we have an implementation of this interface that does not implement the interface completely. So what we have done is we can go here, just say implement missing members. Okay. And now we need to implement this. So what we did is we are enforcing through the compiler that a client of the error API must handle all kinds of errors. So if we create a new kind of error, if we don't implement its handling, we get a compile error. So instead of getting a surprise in runtime, oh, we forgot to add this, no, we have in compile time enforcement, so it's harder to mess up. And this is why using this strategy is cool. And it is also, unfortunately, a non-trivial amount of work because C# doesn't support this out of the box. So we have to implement all of this to achieve it. Other languages make it easier to do this, but at least we can. So even though we probably won't use this all the time because it's a bit annoying to implement, we can do it. So in some cases, and like this one is a good example, I think, we can do this kind of enforcement. Now, just before going into the next bit, we can just take a look here and see the implementation of a visitor. In this case, we'll see it in action later. But basically, we're implementing the error visitor to convert these domain errors into ASP.NET Core MVC's action results. So and it's easy because these kinds of errors map well. So we have like a not found because we couldn't find the group, and we just map it to a 404. and an invalid, we map it to a 400. Or maybe an unauthorized, and we map it to 4O something, 401, 403, unauthorized. I'm thinking maybe this should not be unauthorized but forbidden, but I'll take a look at that later. But you get the picture. So this is it for this implementation. So we have the error, and we will make use of this instead of throwing exceptions, because these are kinds of errors that will happen during development and are normal errors because they are part of the business logic. Otherwise we wouldn't be checking that in the business logic. So we shouldn't throw exceptions, because exceptions are bad for performance and are things that are not explicit, may happen, and we are writing code and we don't know. So this is an alternative to throwing exceptions for domain logic. Now that we have an error type, the problem is how do we use it? Because if we have an operation like a do rename or get something, imagine we want to fetch a group, but the group doesn't exist. We want to return, when the group exists, we want to return the group, but when it doesn't, we want to return the not found. So it's a bit, how do we do it? So in functional languages, and not only that, but normally there is the concept of the either type. And for instance, we have the Scala has it, other languages has it, but basically represents, it's like a pair, but that means that we have either one or the other. Normally used left and right. And the common convention is left is for an error and right is for the success. So getting back to the code, we can go here and have either. So there are implementations of these types, so you can just use a library or something like that, but for demo purposes I implemented it myself, and there are multiple ways to implement it, but I implemented it similar to the error as a tagged union. So basically we have an either left or right, and then in here we have a type left and a type right, and the thing is having left having one type and right the other. So when we have an either type, even though it has two types in its signature, each instance will only have a single type. That's why we can represent it with a class left that only gets one, or a class right that also only gets one. And by doing it this way, we can pattern match on the left or right. So we could do something like go here, I can delete this part. Let me go here to my sheets. Over, where did I put that? Over here. So this is C#8 syntax, but imagine by doing it this way with left and right as classes, we can pattern match and just do switch, left do something, right do another thing. But doing this in all the places may be a bit annoying, so we can create some helpers. Just before looking at the helpers, I was forgetting to help build this either left or right. We can just do a new as usual, but it ends up being a little bit less code if we create an either class without the thing, then left generics, and then it's easy to create a new one. So For instance, we can see I have some helpers here. I created like a static class result, and when it's success, we just do either write and the value, and when it's invalid, it's either left, and we create the correct error. Same for not found, same for unauthorized. We didn't need this, but just a bunch of helpers. And also we didn't need this, but cleans up the other code a bit, because by being able to put the values in there, it's less generic parameters we need to write. Okay, so how can we do this but without having to write these all the time? Sometimes we need to write something like that, but not all the time. So like we did in the previous episode to handle the optional type, we can also create some extensions on top of either to simplify and end up with code similar to link, which I think most C# developers like. And we have either extensions, and we can create some things. That code that I showed you, this one, with either left, either right, we are using it here, but it's being hidden in here. So, and one of the things that makes writing this code in every place annoying is having to put the whole type like this. It's a bit annoying. So if we can avoid, better. So over here we have a method called fold, and I'm not inventing anything. This is common naming for these kinds of methods in functional languages, which the only thing basically that it does, it's calling this, but in a different format. So we have a left and a right func to convert to left or to right. So to convert this to, regardless of being an error or success, we want always to map to the same output. So that's what it is. We get the function and we simply map left, right, and I'm throwing this exception just in case it's not supposed to get here because it's either left or right, but I don't know. And if I remove this, writer complains because it's not exhaustive. I think the only other thing that could be here is null, but if I put null, it says it's also not exhaustive because it can't see that it's a closed hierarchy. That's what's annoying, but oh well. So throwing an exception is the best thing I can do here to stop it from annoying. But that's it for this fold. So it simply maps either one side or the other to the same output. Then I created an async version, which is exactly the same, but with await and stuff in the mix. Then we have a map function, which basically what it does is, if it's a success, it uses the function. If it's a failure, it just lets it flow. So we use these kinds of map when we want to do, don't know, if for people who have used RxJS, for instance, in Angular, it's something like this. It's if it happens something, it flows. Otherwise, we handle it. So we'll see the code. But basically, we'll also, because it would be annoying for us if there is an error, for us to always be checking for error or success. Most of the times what we want is, if it's an error, let it go. So like the exceptions, letting it go, but more explicitly a little bit. Otherwise, we want to handle the success. And again, a map async and flat map. We won't be using it, but it's just for cases in which we are returning an either inside an either. So in this case, it will flatten. It's like the the same as select and select many. Select many will transform a list of lists in a list. So flat map in this case will transform a neither of either in a neither, so in a single either. But that's it. But no need to go into detail. So now that we've seen the errors, how we use tagged unions, the other type, and the extensions on either type, let's see all of it working together to make something that makes sense. So, getting back here, let's go here and let's see, for instance, the entities group. So the rename method that we already had before throwing some exceptions, but right now it changed. So now what rename does is, if the user is not an administrator, then it's not authorized, because the user needs to be an administrator to rename the group. Then, if the new name provided is null or empty, so it's not valid, because the group can only have a name that's actually a name. And probably this should be improved with some rules, but for now, not being empty is a good enough rule. Assuming it all went well, we can just success. And you can see we are using these helpers that I showed to minimize the code we need to write to use it. So, for instance, in the case of success, we don't need to put any parameter, any type parameter. It will infer this parameter, and because we always use errors, we don't need this. In this case, we need just to provide the type that would be here on the right. The left is always error. So this is for the rename. Simple usage, all good. But now, how do we handle this either? If we go over here to the handler, so the result changed. It now is an either error or update group details result. So it can go well or wrong, and it's explicit. And then over here, the same before we had the optional, and we are checking if we have a group, otherwise not found. Regarding the user, if we don't have a user, invalid, there is no user to create the group, so another kind of error. And then you have this part, which is like more linky, like I was saying. So we have a group, we try to rename, given the correct arguments, and it will return an either error or unit, in this case, unit being the void, like I mentioned previously, I think. Oh, but unit is to simplify, instead of, because we can't put either error or void, we use the unit as a dummy void item. So in this case, rename will return unit in case of success. So we can ignore it. But if it was a success, we want to run this code. That's why we are using map async. We just want to use this map when all goes well. If it is an error, it will flow directly, and we don't need to put additional code here to handle that. No need for ifs and stuff. So if all goes well, map, and it means that the rename went successfully, so we can update the group in the repository. And when it is updated, we can just return the update details. So this is a sample usage of map, and this way of doing things in a functional way, chaining together calls to methods. So if you are used to Link or RxJS, this kind of implementation should be familiar to you. And now, where else we can use this? Previously, I showed you the implementation of the error visitor to convert the errors to web API responses. So now we can go to the web part, features, and let's go to the groups controller and see this in action. So nothing over here, but now we have get by ID async, or better yet, let's keep it, it's the same. So let's see update and add async. So in this case, we're using, as we saw before with mediator, we send it and we get the result. In this case, the result is an either error or update group details. So then I implemented some extension methods on top of either, but specific for the web part. So these extension methods are over here, and we can go here to the result extensions. As you can see, this is on the web because it's specific to map the error to an action result. And we have a bunch of things here. As you can see, we can map a result. We have a couple of overloads. The only difference is this value mapper. When we want to convert, for instance, the result to a DTO or something like that. And basically we are using the fold method that we saw, the extension method on top of either. And when it's error, we call this to error result, and you'll find this here. So we're using that visitor pattern that I mentioned and passing in that visitor that we saw that maps the results, the errors, to action results. So this is that implementation. So in case of error, we use the visitor to map the thing. In case of success, over here, it's just an extra. If it's, so I'm adding some defaults because it makes sense. So if it's a unit, which means it's like void, we can return a 204. If it's not unit, so it's some actionable interesting type, then we use the value mapper and convert it to return a 200 with that object in there. And that's it. So we are using fold over here, the visitor pattern for the error part, and in the success we're just doing an extra bit to do a 200 or 204 depending on the type that we get. This method is exactly the same. The only difference is that the value mapper is provided instead of just being the default. Get back to the controller. So this is it. So we are making use of these either extension methods, creating extension methods that build on the other extension methods, and then we achieve this kind of code in the controller. Okay, don't know what's happening. Something, I'll need to pause the video because something is throwing. Sorry about that, my pointing application crashed. Oh well, let's continue. So we can achieve this kind of code in the controller, where we just proxy the request to the domain layer and then map it with those extension methods, which makes this code simpler, probably. Some people might not like reading it like this, but when defaults work, we can reduce the code a lot. In add async, we have something very similar. So this part is the same. In this case, we are just using a different method. Let me just show you. It's the same as the other two over here, but the difference is because over here we're making assumptions that we want a 200 or 204 in the success result. But maybe we want something different. So we keep using the error the same, so delegating to the error visitor. But in case of success, we delegate totally to the client of this extension method. And in this case, on the add async, we don't want a 200 or 204, we want a 201. So the goal of this method is to have something halfway, so we can still work with the visitor. We could anyways, but in this case we abstract some a bit, so we can still take advantage of that, of the visitor, in an easy way. But in a success way, in a success case, we can control it ourselves. So worst case, we can ignore these extensions and do it. For instance, in the remove, we are not using that, just no content. Over here, the result again, in this case, we are using it. In this case, just okay. So it depends on what we want to do. But we can create some extension methods to make our lives easier. And that's it, I think. Let me just check. Yep. So we created that error. We created the visitor. Use the visitor pattern to enforce the correct handling of all types of errors. And then we created the either type to be able to return either success or failure, to make it explicit instead of throwing exceptions and maybe forget to catch them. And then with all those helpers, so sometimes people think, because these kinds of things are not really in C# are from functional languages, would make sometimes the code more cumbersome, but we can in fact use some extra methods, do some things like this to action result, and simplify, and we get controllers for these specific cases that are simple. Of course, if we start to do complex stuff, maybe we need to do some extra manual work. But for the most common things, we can have some defaults and makes the code cleaner. And I think that's about it for today. As always, open for questions and feedback and suggestions to improve these things in next episodes. Hope this was useful and hope to see you in the next one. See, yes.